All right, kiddos, so this is going to be our lesson 5-2/3 video. And what it's going to be dealing with is function composition. Okay, so that brings us right into the first EQ. What is a composite function and how do we quote unquote create it, right? So let's go ahead and answer that first question. And I'm just going to do so verbally, and then you'll see on the next slide exactly what we're talking about. So a composite function looks something like a function within a function. All right. So a composite function is a function within a function. So EQ2, how do we evaluate a composite function for some given value of x? And we'll get to that in the later slides. So here, let's look at what a composite function really is. Okay, so if we evaluate f of 4, so here's f of x, right? And f of x equals 30 plus 20x, right? F of 4, so instead of saying f of x, we're saying f of 4. So basically, all that means for us to do is we're going to plug in, for every instance of x, we're going to plug in 4, right? So f of x equals 30 plus 20x, okay? Except instead of x, I don't know why I said what I wrote what I said. It's early in the morning, cutting some slack. Okay, so f of x equals 30 plus 20x. Okay, so here's our x now. All I did was replace the x with what was here in the parentheses, the 4. Okay, so that's going to give me 30 plus 80, and that is 110. So f of 4 equals 110. Okay, so how do we find the answer? Again, we just plugged in for x. Okay, so now what if let's forget this word composite function for a second. What if I wanted to find, instead of f of x or instead of f of 4, what if I wanted to find f of g of x? Okay, so f of g, right? So what if I wanted to find f of g? Well, I'm going to take g and plug it into f of x. All right? So every instance of x is instead going to have this guy, g. Okay, so f of x equals 30 plus 20x. Now instead of x, I'm going to use here in pink, I'm going to use g of x, which is 4x. Okay, so f of g of x, if I simplify and combine like terms wherever I can, which not many places do that, I'm going to have 30 plus 20 times 4x, so plus 80x. And that is f of g of x. Okay? And you're always going to see the x there, but if you ever see this kind of notation, just f of g like this, that still just means, well, g is a function of x, right? So we're still assuming that it's f of g of x. Okay? Another way that you might see it is f with a weird little circle, and then of g, and then parentheses of x, like this. This, again, that weird little circle thing there, it just means of. Okay, that's it. So if we're saying f weird circle thing g, we're saying f of g of x. Okay, so not to get confused. Okay, so how is the process different from finding f of 4? It really wasn't. So over here, back over here, we had f of 4. We plugged in 4 for every instance of x, right? Over here, we have g of x, so f of g of x, and we plugged in g of x for every instance of x. Because our original function f was just 30 plus 20x, right? We just replaced x with 4x. Okay? Find the composite function g of f of x. So now we're doing it the other way around. We're going to take we're going to take f and plug it into g. Okay, so now g of x, well, g of x is just 4x, right? g of f is simply 4 times, well, we're going to plug this guy in right over here, okay? This guy right here is f of x, and this guy's going in place of our function of x in g. Okay, so instead of 4 times x, we have 4 times f of x, right? Which is equal to 4 times 30 plus 20x. Now we're going to distribute, and that's going to give me 120. Oops, yeah, no, that's right, brain fart. 120 plus 80x, and that would be g of f of x. Okay, and again, all I did was take f of x, right? I took f of x and threw it right here in place of the x. Okay, so now another question. Is f of g the same thing as g of f? So here we have g of f. Here's g of f here in pink. And in green, we'll go ahead and highlight it right over here. Okay, so are these two equal? No. Okay. 30 plus 80x obviously is not the same thing as 120 plus 80x. Okay, not the same thing. All right, so no, they are not equal. Okay, so here we've got 3 functions now. So we're going to write the composite function f of g, right? And again, this weird little circle thing just is a math speak for the word of. Okay, so f of g, so f of g, right? We're taking g and we're plugging it in here to f. Okay, so f of g of x, which is the same thing as f of g of x, like this. And this notation is a lot better, because if you look at this weird little circle thing, it looks like a multiplication dot, and that can get confusing. So if I had a preference, it would definitely be using the parentheses instead of the stupid circle thing. But that's just me. It's up to you. But it's important that you understand the difference, because you're going to continue to see that notation for some reason. Anyway, so f of g, right? So that's going to mean, so if I have f of x, that's x squared. Okay, so that means I'm going to have g of x all squared. And g of x, if we remember, is 2x minus 1. So all of that squared. Okay, so to actually get what f of g is, okay, we're going to have to square 2x minus 1. Well, how do we do that? Well, consider 3 squared. What does 3 squared mean? Well, that means there's 2 3's being multiplied together. So if I say 2x minus 1 all squared, that means there's 2x minus 1's, and they're being multiplied together. Okay, and what we're going to have to do here, is FOIL. Okay, so first, outer, inner, last. All right, so 2x times 2x, that's going to give me 4x squared. 2x times negative 1, that's going to give me minus 2x. Negative 1x times 2x, that's going to give me minus 2x again. And minus x times minus x, that gives me plus 1. And we're going to go ahead and combine like terms. So 4x squared combines with nothing, so we just have 4x squared. Minus 2x, that gives me minus 4x, and plus 1 by its lonesome. So f of g is simply 4x squared minus 4x plus 1. Okay? Now, next question is asking us, well, what is f of g of 2? So basically, what is f of g of 2? right? So there's two ways to approach this. You can plug in g of 2 into f. So you can plug in 2 here. So you can say g of 2 equals 2x minus 1, which would be 3, and then take this 3 and throw it into f, right? That's one way to do it. Or we can take our composite function that we already have, which is f of g, right? And we can go ahead and say, instead of f of g of x, we could say f of g of 2 like this, and just throw 2 in for every instance of x, and we should get the same thing. So what we should get is 9, based on what I did up here, right? So let's see if it works out. So f of g of 2, I've got 4 times x squared, right, minus 4 times x plus 1. Okay, order of operations says we're going to do the exponents first. So that's going to give me 4 times 2 squared is 4. And then minus 4 times 2, which is 8, plus 1. Multiplication is going to come first. 16 minus 8 plus 1. And that's going to give me, so 16 minus 8 gives me 8, plus 1 gives me, holy dog crap, 9. I got the same thing I got over here. So that's two different ways to do it. Okay, that's two different ways to do it. And again, to reiterate, so what I did was take g of 2, right, which gave me 3, and then you plug that into f, so that becomes f of g of 2, which was 3, so f of 3, and 3 squared was 9. Or you can do this way, where I already had the composite function from earlier. Okay, we see that we get the exact same answer either way that we do it. Okay, so let me erase and give myself some room. Write the composition g of f in terms of x. So we want g of f of x, otherwise known as g of f. We can just say g of f if we want to. Okay, so g of f is going to be 2 times, so here, let me start over. Well, not start over, but okay, so g is 2x minus 1. Okay, and f, I'm just going to transfer my stuff down here so it's right here where you can see it. F of x is x squared. So if I'm saying g of f, right, I'm going to plug in f for every instance of x in g. Okay, so I'm going to have 2 times, instead of x, it's going to be x squared. And there's no other instance of x, so that's it, I'm done. So my answer for g of x is simply 2x squared minus 1. Okay, and that is my g of f of x. Okay, so same idea as before. Evaluate g of f of 2. And again, this is g of f of 2. Okay, so there's two ways to do this. I can plug in 2 here into f, right? So f of 2 equals x squared, which is 4. And then I can plug that guy into g. So that would be g of 4. So that would be 2 times 4 minus 1, which would be 8 minus 1 is 7. Okay, so my answer I should get is 7. Now I'm going to do it using my composite function, and I should get the exact same answer. Okay, so 2x squared minus 1. Let's see how that works out. So 2 squared gives me 4, so I've got 2 times 4 minus 1. So that's going to be 8 minus 1, which is also, holy dog crap, 7. Okay, so either way you choose to do it, it's still going to work. Okay, so we've got 3 more functions. So let's evaluate h of g of 3. So we don't have the composite function right off the bat. Okay, so what we can do is, well, what is g of 3? We can go ahead and calculate that, right? So 2x minus 1, and that's going to give me 6 minus 1, which is 5. Okay, now we want h of g of 3, and we just calculated g of 3. G of 3 was 5, so we can also say that this is simply h of 5. Okay, so h of 5, we'll go ahead and do that. H of 5 equals negative 4x minus 3. Okay, negative 4 times 5, negative 20, minus 3, negative 23. So h of g of 3 is simply negative 23. Okay, if we write it in terms of x, we can kind of check our answer. If we write it in terms of x and just try it again, just to make sure that we've got it, we can kind of check our answer. So that's what we're being asked to do on number 12. So h of g of x, so h of g of x, okay, so h of x is negative 4x minus 3, so negative 4, for every instance of x, I'm going to plug in g of x. So negative 4x, right, minus 3. And g of x, of course, g of x is 2x minus 1. So let's go ahead and do that. So negative 4 times g of x, 2x minus 1, and minus 3. Okay, the g of x is right here. And again, just to make sure we've got it, h of x looks like this, negative 4x minus 3. And you can see where everything went. Okay, g of x got replaced, or sorry, x got replaced with g of x. Okay, so if we go ahead and distribute that negative 4 into the parentheses, that becomes negative 8x plus 4 minus 3. Combine like terms, we are left with negative 8x plus 1, and that is our h of g of x. So now let's do h of g of 3 just to make sure we're getting what we're supposed to. So if we do h of g of 3, that becomes negative 8 times 3 plus 1, negative 24 plus 1, negative 23. Holy dog crap. Same answer. Evaluate g of 2. Okay, so that's a mouthful to try and say a little bit. So we're basically going to use g twice. Okay, so we're going to have g of x within g of x. So right here where this x is, I'm going to replace it with g of x again. Okay, so let's see what that looks like. So g of 2. Okay, so first let's find, well, what is g of 2? So g of 2 equals 2 times 2 minus 1. That would be 4 minus 1, which is 3. So that would be, this right here, g of 2 would be the same thing as g of 3, because g of 2, right, g of 2 was 3. So g of 3 would be 2 times 3 minus 1, and that's going to give me 5. Okay, so if we do it in terms of x, so that's more with the intent on what I was going to do. So g of x is going to look like this. 2 times g of x minus 1. Okay, so now I'm going to plug in for g of x with g of x. Okay, so 2 times g of x minus 1. And that's going to give me 4x minus 2 when I distribute, right? Minus 1, which is 4x minus 3. Okay, and when I plug in, so when I say g of, what was it, 2, right, like I did over here, I should get the same answer. So 4 times 2 minus 3, and that's going to give me 5. 4 times 2 is 8, minus 3 is 5. Okay, so I know that I'm correct. Okay. So every once in a while you'll see these, especially when we get into college algebra. Okay, so it's good to understand how this works. Let me pick a more neutral color. Okay, so f of 3. Okay, so not f of x, right? F of 3. Okay, so f of 3 is this guy here. F of 3 gives me 1. So f of 3 is 1. G of 3. So not g of x, but g of 3. So here's x equals 3. G of 3 would be this guy here. G of 3 is 2. G of f of 3. So what was f of 3? F of 3 was 1, right? So g of f of 3 is g of 1. Okay, g of 1. Oops, that's not g, that's f. What's another thing? G of 1. Okay, so that would just be 4. Same thing over here. F of g of 3. Again, we already know what g of 3 is. It's 2. So instead of saying f of g of 3, we can just say f of 2. Okay, so f of 2 gives me 2. Okay, we didn't have an actual function to go off of, but we knew numerical values for f and g in these tables, right? And from that, we were still able to evaluate the functions as functions of each other. Okay, so back to our EQs. What's a composite function? Again, that's simply a function within a function, right? How do we create it? I'll leave that one to you to answer. I think what we're meaning to ask here is, where do they come from, right? So you're basically just plugging in values. Okay, and how do we evaluate a composite function for some given value x? Again, that's just plugging in numbers. Okay, so if you have any questions over this, let me know, or Miss Roundtree, depending on which one of us you have. Obviously, we're available to you guys by email anytime. Come through tutoring anytime you need it, and make sure and take awesome notes over this video. Okay, signing off.